Today we will talk about the first chapter for class 10th chemistry, that is chemical reaction and equations. The summary of the lecture is we will talk about chemical reactions, we will talk about chemical equations, ba balanced and unbalanced equations, how to balance a equation, and also law of conservation of mass. And then we will see some examples of different equations and how to balance them. All right. So chemical reaction is a form of chemical change that occur when two or more substances combine to form a new substance. So when two or more substances or atoms or elements or molecules are reacting to form a new molecule, that is called the chemical change, and that chemical change is called chemical reaction. So generally, in a chemical reaction, two things are required. One is a reactant. Those are the substances which are reacting, and the next is product, which is basically what's forming. So as you see in that equation in front of you, that A and B are the reactants, and they are on the left hand side of the arrow. That arrow represents they are reacting and going towards the product, which is A and B. They both combine to form AB product. That direction of the arrow is important because that shows in which direction the reaction is happening. For example, in this case, A and B are reacting to form a product AB. Let's assume that direction of that arrow is reversed. In that case, AB would be the reactant and it's going to decompose into A and B, two products. So that direction of arrow is important. And in any reaction, you should always remember two things which are very essential is reactants and products. Reactants are the one which are reacting and product are the one which are forming. Okay. So a couple of things which happen during reaction is good to note at. First of all, rearrangement of atoms. Second, old bond breaks and the new bond forms. Third is elements remain the same. Let's talk about each and every one of them in a little bit more detail. So let's take an example of a reaction which is happening between carbon and oxygen and it's forming carbon dioxide. So in this case, as you can see, the old bond between two oxygen atoms is broken to form a new bond between both the oxygen atoms and the carbon. Another thing to note that in the reactant side, you only have carbon and oxygen. Similarly, on the product side, you only have carbon and oxygen. So in this reaction, we are not forming the new elements. For example, when carbon and oxygen are reacting, we are not forming a nitrogen. That's what elements remain the same means. If carbon and oxygen are reacting, you only will get carbon and oxygen in the product. You will not get nitrogen or hydrogen or magnesium or calcium, anything like that in the product. It will always be carbon and oxygen. Rearrangement of atoms. As you can see, the atoms are rearranging in this reaction. Let's take an example of burning of magnesium ribbon. This is in a textbook example of a typical reaction which happens. So if you are looking at this schematic, what we are seeing is there is a magnesium ribbon rod, as you can see in the text there. We are lighting that magnesium ribbon using a burner, and then we are holding that magnesium ribbon by a pair of tongs. It's important, don't hold it by your hand, otherwise you will get burned. So use tongs just for safety. Now, when you are using a burner to light the magnesium ribbon, couple of things happen. First is you start seeing a light, white light coming out. And second thing you see is the formation of a white powder. Now, in this case, we have put a china dish in the bottom that is basically collecting that white powder which is forming as a result of this equation. So if I have to say what I observed in this chemical reaction, first thing we will say is the magnesium ribbon burns with dazzling white flame. Okay, and then it's changing into the white powder, which is forming and collecting in the china dish in the bottom. That white powder is actually magnesium oxide. So this whole setup, which we just talked about, is a chemical reaction. In this, magnesium is reacting with oxygen in the atmosphere to form this magnesium oxide. You see an example of this like in your firecrackers in near Diwali. Generally, जब firecracker में white light निकलती है वो magnesium इसी process से निकलती है. Then you also have red color, you also have like orange color. All are burning of different elements. Okay. So what we saw that due to the reaction between magnesium and oxygen, we see a white light and the formation of magnesium oxide. Very interesting point to note that magnesium is a very reactive metal. Okay, so when you store that magnesium like in atmosphere, then it forms a layer of magnesium carbonate on the surface, just on the surface, just a little bit on the very surface, and that magnesium carbonate is not reactive. Okay, so it's like a passive element. So now, if I want to burn magnesium, or the experiment we talked about just before, then it would be very difficult because on the very surface you don't have magnesium, you have magnesium carbonate. So in order to burn the magnesium effectively, we always clean the magnesium metal with a sandpaper before burning, and that is basically to take away that magnesium carbonate out. So this question is asked many times in the exam, so please remember this, that every time whenever we burn a magnesium ribbon, we have to clean it by sandpaper, and that is because of the reaction between magnesium and the air, which is atmosphere, to form magnesium carbonate, and which hinders or doesn't allow the burning of magnesium um, in and formation of magnesium oxide. So before that, we always clean it by sandpaper. Another example is this formation of hydrogen gas. So you see on your slide that we have a conical flask, and we have a sulfuric acid, and we have zinc granules, and then due to this reaction between the zinc and the sulfuric acid, it forms hydrogen gas. This is another example of chemical reaction. Now, how do we know a chemical reaction has taken place? That is like, what are the characteristics that will tell us whether a chemical reaction has taken place? And these are some of the characteristics, as you can see. Change in state. For example, liquid is going into gas, or gas is going into liquid, or solids, or phases are changing, interchanging there. That will indicate the chemical reaction is going on. Change in the color. For example, you have two molecules in the reactants, yellow and blue color, and they are forming a red color product. And then change in color that is happening there is an indication that chemical reaction is going on. Evolution of gas is another example. Also change in temperature. For example, if you are reacting A and B and forming AB, right? And then you see there is a heat is coming. You see that your beaker is becoming more and more hot. That would be an example of chemical reaction. So these are the indications that will tell you whether a reaction is happening or not. Now the big question is, can we simplify the chemical reactions? For example, we talked about magnesium and oxygen are combining to form magnesium oxide, and that has like light is coming out. There's a big process going on. Is there a way we can simplify that reaction? And in the previous example, we looked at the zinc is reacting with sulfuric acid. So this whole things, uh, this process, this chemical reaction is happening. How can we simplify it? So that we can explain it to different people, we can note it down, we can look at it in a more concise way instead of each time drawing the picture. And that is answer is yes. And then we can do that by chemical equations. And next we will talk about chemical equations. Now this chemical equation can be in two parts. There are two ways to represent a chemical equation. First is by using a word. You can actually write that magnesium is reacting with oxygen to form magnesium oxide. So if you look at the previous example, the word equation would be just writing the magnesium and oxygen and forming the magnesium oxide, explicitly writing it. That's what word equation means. Okay. Another way, and that is more practiced way and easy way, and actually is more concise, is using symbols. What in So basically symbols are, you represent magnesium by its atomic symbol, oxygen by oxygen molecule, magnesium oxide by magnesium oxide. So that would be a symbol equation of the chemical reaction. So there are two ways to represent a chemical equation. One is word format, which we looked at, and symbols format, which is the last one on this slide. Very important topic, law of conservation of mass. Mass is always conserved. Just remember this, just put it in your mind. Conservation of mass. Mass in is equal to mass out. Whatever is reacting, the mass of that reactants is always going to be same as mass of the product. So we are not going to make new mass in a reaction. Just remember this. We will not create or destroy the mass. We cannot do that. If 5 kilogram of the reactants are reacting, then 5 kilogram of product is going to form. Okay. It is just the law. Okay. Just remember it by heart. So if we have a reaction, as we talked about, any reaction or equation has two main components. One is reactants, another is products. So total mass of elements in the reactant side is always going to be equal to total mass of elements in product side. And that is going to happen all the time. There is no exception to it. Okay, just remember this. This is very important. Now, when you write a chemical equation, in order, it always has to satisfy the conservation of mass. Okay, now to make it satisfy conservation of mass, it has to be balanced, and we will talk about what that means. So now think about what's going on here in our daily life. Let's say we are in Diwali hai, or आप rocket चला रहे हैं, and that rocket, let's assume, has a magnesium. Okay, तो जैसे वो मैग्नीशियम अपन लाइट करते हैं रॉकेट को, वो ऑक्सीजन के साथ रिएक्ट करके मैग्नीशियम ऑक्साइड फॉर्म करता है, और व्हाइट लाइट भी दिखती है अपन को स्काई में. Okay, so that's going on. So if you think about this, all the magnesium which is present in the rocket, let's say it is 1 gram. Okay, and it is reacting with, let's say, 2 grams of oxygen. So 1 gram of magnesium is reacting with 2 grams of oxygen, and then it forms magnesium oxide. So now we know from conservation of mass that the a mass of that magnesium oxide is going to be 3 grams, which is 1 plus 2, right? So this is the reality. This is going to happen in actual life. Now we are representing this equation by this word format, which is magnesium and oxygen is going to form magnesium oxide. Okay. This equation also has to follow that law, because reality follows the law. So we have to make sure our reactions and the reality is same thing. So that's what we are going to talk about. How to balance the equation, which is chemical equation, which we just wrote down in the previous slides, so that they always follow conservation of mass. So there are two type of equations. One is balanced equation, another is unbalanced equation. So balanced equations are the equations which follow the conservation of mass. Unbalanced one, they do not. So when number of elements in the reactants is equal to product. So whatever is in the reactants, same amount of mass is actually in the product. For example, if you have 4 oxygen atoms in the reactants, then you also have 4 oxygen atoms in the product. And this will make sure that your conservation of mass is applied. So let's look at this equation, which is zinc is reacting with sulfuric acid, and then you are forming zinc sulfate plus hydrogen. In this equation, you see there is 1 atom of zinc on the reactant and 1 atom of zinc on the product. There are 2 atoms of hydrogen on the reactants and 2 atoms of hydrogen on the product side. Similarly for sulfur, similarly for oxygen. So number of atoms in the reactants is equal to number of atoms in the product. And this will make sure this equation is following the conservation of mass, because if the number of atoms are same and each atom has the same mass, then the mass in the reactants would always be equal to mass of the product. Unbalanced equation doesn't have this. In unbalanced equation, the number of atoms in the reactant is not equal to number of atoms or elements in the product. Okay. So for example, this magnesium and oxygen reaction we talked about, we have one atom of magnesium in the reactants and one atom of magnesium in the product. So that is fine. But if you look at oxygen, we have two atoms of oxygen in the reactants, but we only have one atom of oxygen in the product. So this is not balanced, and that will not follow the conservation of mass. So we have to make sure our equation follows the conservation of mass, and we can do that by balancing it. Okay. Now, how do we balance equation? A couple of ways. First one is just hit and trial. For example, in the equation you're looking at, if you just put some of the numbers on the reactants and product side, then you might be able to balance it. So the example we talked about, magnesium and oxygen going to form magnesium oxide, which is not balanced, right? It's unbalanced equation. If I have to write the element and then number of atoms in the reactant and number of atoms in the product, as you can see, magnesium, we have 1 both in reactant and product, but oxygen, there are 2 atoms in reactant and 1 atom in the product. So if we just multiply the equation, like in the reactant we multiply the magnesium by 2, and in the product we multiply the magnesium oxide by 2. When you put that number there, it will become balanced. So this is the hit and trial method, because we are trying to just eyeball it, just trying to guess what the number would be. And then if we get lucky, we would be able to balance it. Simple equation like this can be balanced like this. But there are complicated equations in which you have bigger molecule. You have more atoms. You have a lot of products, a lot of atoms, and then it would be a nightmare to actually balance by hit and trial. So there is a more systematic approach. So first step in that systematic approach is basically to draw boxes around each of your formula in the equation. So in this systematic approach, we will see an example of iron is reacting with water. So first we draw a box around each and every formula. Next, we list down the number of atoms of different elements in that boxes. So um, as you can look, there are 3 different atoms here: iron, hydrogen, and oxygen. So number of atoms in the reactants is iron is 1, hydrogen is 2, oxygen is 1. But number of atoms in the products, iron is 3, hydrogen is 2, and oxygen is 4. The third step is basically, now you select an atom which has maximum number in reactants or product. So in this equation, we can see oxygen in the product has maximum number of atoms of 4, right? So to balance, first of all, we will start with balancing the oxygen atom. To balance the oxygen atom, we just multiply that oxygen atoms in the reactants by 4, because we have 4 oxygen atom in the product. So as you can see in the equation, in the box equation, I multiplied on the left hand side, that is the reactant side, only the water molecule by number 4, because water is the only molecule there which has oxygen. So now if you look at the equation, which is partially balanced because their other atoms are still not balanced, but we have same number of oxygen atoms in the reactant and in the product. Another very important point to note is you cannot modify the formula, okay, or reactant in the equation, and that's why we put the box around all the formulas, and so that you cannot change the formula. So water, you cannot make it H2O4 to balance the oxygen, or H2O and then bracket 4 to balance the oxygen. Okay, that is not, you cannot change the compound. Okay, you can only change the number of that molecules. Now that's why putting a box around to make sure we don't make a mistake. Okay. So now we have a balanced equation from oxygen point of view. Our hydrogen and iron is still not balanced. So as you can guess, our next step would be to balance with either hydrogen or iron point of view. So let's say we want to balance from hydrogen point of view. Okay, so we have um, in reactants we have 8, and in products we have 2. So what we can do, we can multiply the product by 4, so we will have 8 in the reactant side and 8 in the product. So that you can see in the box equation, I have multiplied the output, which is the product, by number 4. Now we have 8 atoms of hydrogen in the reactants and 8 atoms of hydrogen in the product. So this equation is balanced from hydrogen point of view. But our iron is still not balanced. So let's do the same exercise. We see that we have 1 atom of iron in the reactant and 3 atom of iron in the product. So we multiply the reactant by 3. So we will have 3 in the reactant side and 3 in the product. As you can see in the box equation, our iron atoms are also balanced. Now we have a balanced equation, but we have to do a final check. And that is basically to make sure we have done our job right. We just list down all the elements and then number of those elements in the reactant and number of those atoms or elements in the product. So iron we have 3 3, hydrogen we have 8 8, and oxygen we have 4 4. Now we can be sure that our equation is balanced. And we can also say this equation obeys the conservation of mass. All right. Another important thing to note is like we do add few more characteristic in equation, that is to add some more information. For example, if we have a solid in the equation, we put a little s there just to make sure we know that it is solid. Similarly, for liquid, we put in the bracket small l, small g for gas, and if say our reactant and product is in solution of water, we put aqueous, which is aq dot. Okay. Now let's look at previous equation. Our iron was actually solid, so we put S there. Our hydrogen was actually in the form of steam. We are not using the liquid water, we are actually using the steam, and that's why we put G there. The product we are forming, similarly, we put the states, physical states, in the product too. As you can see, our hydrogen is actually in the gas form. So this is not all the time we add these information, that is the physical state, but if required. There are other examples of balance equation, and I would recommend all of you to actually look at the equation and try to balance it yourself and check the results.